Okay, today we're taking a look at the final 5 AMC 8 problems of the 2020 AMC 8 competition. So we're going to start with problem 21 right here. So a game board is 64 squares. It's basically a chessboard, right? It's alternating black and white, just like a chessboard. And you've got square P in the bottom row. That's right here. And you've got square Q in the top row. A marker is placed at P, and a step consists of moving the marker into one of the adjoining white squares, so one of the diagonal white squares in the row above. So because we can only go to the row above, we're only heading in this direction. How many 7-step paths are there from P to Q? The figure shows a sample path moving from like in this zigzag direction. Okay, so we can start by listing out some possible ways from P and then ending up at Q, right? So we can start just with the first step. So we know that if you're at P, you have to go either here or here. Those are your only two options. Now, once you're at this point, we can continue. We know we can go only to either here or to here. On this one, you can go either here or here. And so we continue, right? Either here or here. This one can go either here or here. Now, this one, you're at the edge of the board, right? So you can only go towards the top left. Continuing. And here, this one we have to be careful, right? Because we've already done 1, 2, 3 steps. So we can't go to the left anymore because that would be our 4th step, and then 5, 6, 7. It's not possible to get to Q in 7 steps. So this is the farthest left you can ever go on any path in order for it to be 7-step paths, right? Because 1, 2, 3, 4, and then you have to keep going to the right. So 1, 2, 3, 4, 5, 6, 7. So our only option from here is to go to the top right. And so the rest of our paths fill up pretty easily, right? Once you're here, you can only go towards the top right. Here you can go either left or right. Again, being on the edge of the board, you can only go left, either to the right or to the left, and like this. And so here we have a map of basically all of our paths that we can take for a 7-step path from P to Q. So now we're going to do what we call the flowchart method, right? And here's how it works. So we're going to start at Q, at our destination, and we're going to look 1 step back. So if you're at this point, there's only one way you can get to Q from here, right? Without going backwards and taking more steps. The shortest path possible is 1 step, and there's only one way to do this 1-step path. So we're going to write the number 1, because there's one way to get to Q from here. Right, now we're going to look at this one as well. And this is very similar to the square we just handled, right? So there's exactly one way to get to Q, so you're going to write a 1 right here. Now let's look at this square. There's 2 ways to get to Q from here, right? You have to take a 2-step path, and either through the left or through the right. So there's a total of 2 ways. So note that this is just basically adding 1, because there's a 1-step path, to this square, which there's 1. And there's also 1 to this one. So it's sort of like pouring water into the top, right? You get a split here into 1 and 1, but they combine here to give you 2. So you add these 2 vertices and it'll give you 2. And that's why it's called the flowchart method, because you're always adding up vertices to get another path number. So if you look at this point, this is another point. The shortest distance between here and Q is 2 diagonal steps, right? And there's only one way we can do that, though. You have to go straight to the right every time, to the top and to the right once every single time. Again, that's the same thing for this vertice and this vertice, because you have to go in this direction from here straight to Q. There's only one way you can do that, so we're just going to write a 1 by that vertice. So now we can do what we did before, right? We're just adding up the 1 and the 1, and we're going to do that for all of our vertices. So this 1 and this 2, it adds up to give us 3 right here. This 1 and this 3 adds up to give us 4. This 1 and this 4 adds up to give us 5. Now we can continue with this. So this vertice, we have to be careful. It's not 1, right? Because you have the choice to go here. Well, not really the choice, right? You're obligated to go here. And then from here, there's 2 paths. So really, there's a total of 2 ways to get to Q from here, right? You can either go like this or like this. And that's just because, there's only one way to get to this point from here. So it's the same number. So now we can continue adding up vertices. We got the 3 and the 2, so that adds up to 5. 4 and the 5 adds up to 9. This 5 and this 9 adds up to 14 for this point. Now again, the same logic as this 2 and this 2, this 5 and this 5 will stay the same. This 9 and this 9, or I'm sorry, now we have a 9 and a 5 here, so these two have to add up, give us 14 at this vertice, and there's 28 right here. 14 plus 14 is 28. So by the flowchart method, we can see that there's 28 7-step paths from P to Q. So our answer is A. Next question, number 22. When a positive integer n is fed into a machine, we get the output. So this is basically like a function. If n is even, it's n divided by 2. If n is odd, this is 3n plus 1. So this is something known as the Collatz conjecture. That's related to this. It's basically this machine, and they say if you plug in the number n, eventually through some number of repeated inputs, you're going to get the number 1. And that's just a conjecture. I'm not sure if it's been proven or not, but it's not really related to this problem. So we're going to continue. So here's an example with n equals 7, right? It ends up as 26 in 6 steps. So now we're doing the same 6-step process to a different value of n, but the final output is 1. What's the sum of all possible integers n? So the easiest way to do this problem is to reverse engineer this, right? So if you have 1 as an output, as your final output, then the only number that can be here is 2. Because if you put in 2, 2 divided by 2, because 2 is even, it's going to do 2 divided by 2 and give you 1. And obviously you can't have 0 plugged in because 0 is even, so it would divide it by 2. It wouldn't do 3 times 0 plus 1 to give you 1. So 0 wouldn't work as an input, so only 2 is the possible input that would give you 1. With similar logic, the only next possible input is 4. When you put it in 4, it's going to divide by 2 to give you 2. And you can't plug in 1/3 because you can only put in integers into the machine. So 1/3 times 3 plus 1 would give you 2, but because it's not an integer, that's not our next one. So we know this one and this one are 2 and 4 for sure. Now our next part gets a little tricky. So there's multiple options for this next one. This one is kind of confusing. We know that this can be either 8, right? Because 8 is even, so it'll divide by 2 and give you 4. And it can also be 1. Why can it be 1? Well, if you put in 1, 1 is odd, so 3 times 1 plus 1 will give you 4. We're just reverse engineering this all the way back. So now we're going to trace both of these out. Well, we know that 1 can only be 2, right? That's our next input. 2 divided by 2 is 1. And we got that from here. It's the same process, right? So you're kind of repeating this 4-2-1, 4-2-1 pattern. We need one more step. So the 4 again can be either 8 or 1. So now we've traced out a full path, right? This is 1, 2, 3, 4, 5, 6, 7 numbers and 6 steps. So these are 2 possible values for n. So now we need to trace out the top half at this fourth number, which is 8, right? So 8 can be either 16. The 16 is even, we'll divide by 2, give you 8. There's actually only one step, so I should rewrite this. Because you can't have 7/3 plugged in, because 7/3 times 3 plus 1 is 8, but again, only integers. So 16, now this one can be either of 2 options. You can either have 32, because 32 divided by 2 is 16, or you can have 5. Because 5 is odd, 5 times 3 plus 1 would give you 16. Okay, 32 will only have one possible option right here, which is 64. 64 is even, 64 divided by 2 will give you 32. And 31 divided by 3 could be plugged in here, but again, only integers. So now let's look at 5. The only possible one for 5 is 10. Because 4/3 would work and give you 5, but it's not odd and it's not an integer either. So we have our 7 numbers here, so we've completed our iteration of this tree. And so you got 4 distinct numbers, 64, 10, 8, and 1. So you just add these all up because we're trying to find the sum of all such integers. 74, 82, 83. Our answer is E. Problem 23. 5 different awards are to be given to 3 students. Each student's getting at least 1 award. How many different ways can the awards be distributed? So we can have the situation where there's one student getting 3, another student getting 1, and the final student getting 1. 3 plus 1 plus 1 is 5. And you can also have the situation where there's 2, 2, 1, right? 2, 4, 5. Now, these are the only two possible distributions, but you can have any variation of these, right? So the first student can get 3, 1, 1, or it can be 1, 3, 1, or 1, 1, 3. And again, for this, it can be 2, 2, 1, 2, 1, 2, or 1, 2, 2. So these are the only possible arrangements, so we'll just stick with these for now and figure out how many ways can we distribute the awards, right? Because they're different awards, so it does matter who gets what. So for this first one, we'll look at 311 first. First, let's figure out how many ways can you pick 3 awards to give to this first student. Well, that's basically just saying how many ways can we pick 3 awards out of 5. So that's 5, choose 3. 5, choose 3. Times. So now you're left with 2 awards and you need to distribute it, one student getting 1 award and the other student getting the other. So this is basically just 2, choose 1, right? And the final award just has to go to the student, so we don't really need to multiply by anything. But we do need to multiply by different arrangements, right? Because we don't know which student is getting 3, which student, and which are the other 2 students getting 1. So we need to multiply by all the possible rearrangements of 3, 1, 1, which is pretty easily 3. It's 3, 1, 1, 1, 3, 1, or 1, 1, 3. So we need to multiply it by the number of rearrangements, which is 3. And this will give us our total of 5 choose 3 is 10, times 2 is 20, times 3 is 60. Alright, so now let's look at our 2, 2, 1 arrangement. So first, we're just going to do the same thing that we did with 3, 1, 1. So first we need to figure out which 2 awards we're giving to the student, which is 5 choose 2. We're choosing 2 awards out of the 5 different ones. Now you have, after you've picked 2 awards, you have 3 awards remaining. So we need to pick 2 for the second student. So it's 3 choose 2. And the last one is just given to the student, right? But we do need to multiply by the number of rearrangements again. So 2, 2, 1, or 2, 1, 2, or 1, 2, 2. So there's 3 of these. So that's why we're multiplying by 3. This is 5 choose 2 is 10, times 3 choose 2 is 3, times 3 is 90. So we just add 60 and 90, and this gives us 150 total ways. B. 24. A large square region is paved with n squared gray square tiles, each measuring s inches on a side. Alright, so this is S, I guess. A border d inches wide, so this is the border, d, surrounding each tile. And the figure shows the case for when n equals 3, because I guess there's 9 squared tiles, 3 squared. When n equals 24, okay, so you got like a way bigger square, the 576 gray tiles, so it's going to be way bigger than this, is covering 64% of the area of the large square region. So I guess that's this big white square. And we want to find the ratio of d to s, where d is the border and s is the length of each gray tile. So we're going to do what we always do, which is set up an equation, right? So 64% of the area of the large square region. We need to figure out what over what is 64%. So we need to find the total area of all the gray squares. So we know there's 576 of them, right? Or 24 squared tiles, times the area of each of these, because 576 of these individual areas. So the area of one of these is s by s, or s squared. So 24 squared times s squared. And that's the area of all the gray stuff, right? And 64% of the total big white square is covered by the gray stuff, so you need to divide by the total area. So we need to be careful in this part. So you can see, we can just look at the 3 case, right? Because it's easier to visualize. We got 3 s's. We're trying to find this length. So 3 s's plus 1, 2, 3, 4 d's. So 3s plus 4d is the length of the large square. for the case n equals 3. So we can extrapolate this when n is equal to 24. So you got 24 gray squares. The length of this whole thing is going to be 24s plus 25d, because there's going to be 24 d's for each of these squares, and then there's going to be one final d at the end. So this makes sense, right? So 24s plus 25d is the length of the biggest square possible, this big white square, for the case n equals 24. So the area of the total large square region is going to be this length squared, right? Because that's the area of a square. So this is 24s plus 25d squared. So this is super messy right now, but we got to notice that everything on this right hand side is squared. So we're going to take the square root of both sides, which we can do because it's an equation, right? So you get 8 over 10, that's the square root of 64 100, right? Is equal to, now the square root of 24 squared times s squared is 24s. And then the square root of something squared is just itself, right? So you get 24s plus 25d. So now you're going to distribute to both sides. You're going to multiply both sides by the denominator, right? So 8 times 24s, that's 192s plus 200d is equal to, this is a 10, not a 6, 240s. Subtracting 192s from both sides gives us 200d is equal to 48, right? 48s. So now if we want to find what d by s is, it's just dividing both sides by s and by 200 equals 48 by 200. And this simplifies to 12 over 50 or 6 over 25. And that's A. Alright, number 25. You've got some rectangles and some squares combining to make a rectangle that is 3322 units wide, like this, wide, 3322, and you got 2020 current year units high. We want to find the side length of S. Okay, so to avoid confusion, I'm going to name the side lengths of S1. This is going to be A1, this is going to be A2, this is going to be A3. So these are the side lengths of our squares, A1, A2, and A3. And now we know that A1 plus A2 plus A3 has to equal the side lengths, right? Because they line up perfectly to combine and give us 3322. So A1 plus A2 plus A3 is 3322. Cool. And now we can use the other piece of information that's given to us, which is the height. So we need to figure out a way to combine these three lengths to give us 2020. And because they're squares, we know that the height of S1 is also A1, the height of S2 is also A2, the height of S3 is also A3. So we need to be careful when we're doing this. We need to see that A3 minus A2 is going to give us this. A3 minus A2, right? Because you're taking this length and you're subtracting this length from it. So that's what A3 minus A2 will give. So A3 minus A2 is this part, right? Then we're going to add A2 plus A2. And then we're going to add this part. And this part is A1 minus A2, right? Because you've got this height and you're taking away this part from it. So this will be A1 minus A2. This is an expression for adding up all of these three parts, which will equal 2020. So I'm just going to simplify this. This is, we have 1A1 minus A2 plus A2 cancels out. So this is minus A2 plus A3. These are equivalent expressions. And this is equal to the height of our total thing, of our total rectangle, 2020. So I'm going to write this equation right here. A1 minus A2 plus A3 equals 2020. Now we're trying to solve for what the side length of S2 is, right, or A2. So we want to get rid of A1 and A3. So what we're going to do is subtract this entire equation from the top equation. And that will get rid of our A1 because it'll be A1 minus A1 and you'll have A3 minus A3. So when you subtract this stuff out, it becomes 0. A2 minus negative A2 gives you 2A2 plus A3 minus A3, that cancels out, right? Is equal to 3322 minus 2020, which is 1302. So you have A2 is equal to 651, if my math is right. And that gives us A.